All right, so we're going to look at problem 2.5, chapter 5, section 2, problem 7. And the numbers I have here is, in a recent study on world happiness, participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 represents not happy, and 10 represents happy. Right? Worst possible life and best possible life. The responses were normally distributed with a mean of 4.5 and a standard deviation of 2.3. And there are 3 questions in here. They want to find the probability that if you randomly choose a participant, they would have given a score less than 4. If you randomly choose a participant, if they would give a score between 4 and 6. And if you randomly choose a participant, if they'd give a score greater than 8. So with any normal distribution, a good thing to start with is let's give our information here in our questions here, is to start with your normal distribution. So I will draw a normal distribution, and our mean is going right down the middle, because the mean goes down the middle, and that's a mu of 4.5. Now, our key for finding probabilities are going to be z-scores. So I'll use yellow for question A. We want to find less than 4. So it's going to be fairly close to the mean, and so we'll say that's 4. And so we want to find the area here. We want to find all of this area. So to find the probability that a randomly chosen person scored less than 4, we need to find the probability of having a z-score of 4. Because our z-tables are left-tailed, we want to look up the z of 4. So the z-score that we're looking at is x minus mu over the standard deviation, which equals 4 minus 4.5 over standard deviation of 2.3, right? Standard deviation of 2.3. So we put this probability, or we put this z-score in. So let's see, 4 minus 4.5 divided by 2.3 gives me negative 0.21739 and so on. But our z-score tables only go to 2 decimal places, so I want to put negative 0.22. Negative 0.22. All right. So if I find negative 0.22 on my z tables here, let me get my z tables up. Go over to the browser. And so I'm on the electronic version of the book here, so I go to tables. I'm going to get my Z table here. So I have a standard normal distribution. I have 2, negative 0.2, and 2, which is 0.4129. So I'll come back over here. And the probability that x is less than 4 is 0.4129. And that gets us through our first probability. Let's look at our second probability here. And so our second probability is between 4 and 6. Now I'm going to draw, right, question B here. What's the probability between 4 and 6? So I'm going to draw another normal distribution here. Whoops, let me put B here. We'll look at B. We want the probability that we're between 4 and 6. And so we'll draw another normal curve. And our mu is at 4.5. And the values we are looking for are 4 and 6. And so we want the area under the curve for here, which will represent the probability between 4 and 6. So to find that, we're going to need our higher our z score and our lower z score. We'll need the probabilities of those. So z high is equal to 6 minus 4.5 over 2.3. Right? And I'm jumping right to the z score. I had done a video before on the z score, but if you want to remember what your z score is, it's your x value minus your population mean over your population standard deviation in the case that we're doing right now. And so 6 minus 4.5 divided by 2.3 is 0.65217 so on. But we only need 2 decimal places for our z tables, so we'll keep the 0.65. And so we'll come back here and we'll go to our positive z table. And we want 0.65, so we come down to 0.6, and over to 0.05 we get 0.7422. 0.7422. So the probability for us of z high is equal to 0.7422. Now we already have the probability of 4. We worked that out in the previous part of the problem, which was 0.4129. So the area in between is the probability of the high z score minus the probability of the low z score, which is equal to 0.7422 minus, and up above, 0.4129. Likes to scroll down. 0.4129. And so the probability of being between 4 and 6, 0.7422 minus 0.4129 is 0.3293. 0.3293. And so we now know the probability if we randomly chose someone if their score would be between 4 or 6. And for part C, we want to know what's the chance of someone being really happy, right? Greater than 8. So what's the probability that x is greater than 8? And again, the habit we should do when doing these is we should draw our normal curve to orient ourselves. We have our mu of 4.5. And we're looking for 8 or greater. We're looking for this here. Now, our tables don't do right tails. So we have to take 1 and subtract the probability that comes from a z score here. So what we're going to be looking at is to get the probability greater than 8, we're going to need the z score of 8. So z is equal to 8 minus 4.5 over 2.3. Right? Our x value minus our population mean divided by the standard deviation of our population. So 8 minus 4.5 divided by 2.3 is 1.521 and 15217 and so on, but we only need 2 decimal places, so 1.52. And so we're going to come back to our table, and we're going to go to 1.52. So we come down to 1.5 and over to 2, which is this 0.9357. 0.9357. 0.9357. And so the probability of being up to 8, the probability of x being less than 8 is 0.9357. But we want the probability that it's greater than 8, which is the complement. And so the probability that x is greater than 8 is 1 minus the probability that x is less than 8, which is equal to 1 minus 0.9357. Or, what is that, 643? 1 minus 0.9357, yep, is 0.0643. And then the last question says, are any of these things unusual? And unusual events have a probability less than 0.05. And not one of these events was unusual. And so this is how we can use our Z tables to help us find probabilities within normally distributed things.